Good morning, everyone. Welcome to NTI Training Institute here at Opal Center. My name is Stanley Kateguru. I am a lecturer in the electrical engineering department, and I train people who are supposed to be on site doing the job. So, in a nutshell, I am a trainer, and I've been in this field for quite some time. You have already introduced yourselves, and we now know each other. Therefore, we can go on with the training. We are looking at working in hazardous areas safely. So that's the core business of the day. We want to be able to work safely on site without any injuries taking place. So that's why you see my title here is working in hazardous areas. So we will start off with a brief definition of what hazardous areas are. If I were to ask any one of you right now, what are hazardous areas? Some of you would give me a kitchen as an example of a hazardous area. True, it is, but we are mainly concentrating on those areas that are in industrial sites where potentially flammable atmospheres exist. So flammable substance is usually a gas or vapor, but may also be dust or fiber. I will kick off with the most popular thing which you are aware of, the fire triangle. In the fire triangle, we have three ingredients. Fuel is the first ingredient. And what is fuel? We are looking at the gas, vapor, or dust. That's what we are looking at as fuel in industry. I know there could be other sources of fuel that can be paper or wood and so on and so forth. But we are looking at gas, vapor, and dust as the fuel. The next ingredient will be oxygen. Always when we are in confined spaces, wherever we are in open places, there is 21% of oxygen in the atmosphere. So that means every time in this room there is 21% of oxygen. We go outside, we also get 21% of oxygen in the atmosphere. The most important thing which I want us to discuss in this presentation is the source of ignition. There are so many numerous sources of ignition depending on the trade. You could be a mechanical person, you could be an electrical person, you could be an instrument person. There are so many sources of ignition which you should be aware of. For example, I've just given you now these ones, the arcs, the sparks, naked flames, and hot surfaces. Maybe right now some of you can tell me what arcs are, and what are sparks, and what are hot surfaces, because we are actually working with these things every time we are on site. Let's look at the ignition sources. Hot surfaces. Hot surfaces can come in different forms. They can be as a result of electric motors running, generators running. Every time electrical equipment is operating, it produces heat, and therefore it becomes a hot surface, which can be a source of ignition. The pipes, when it is too hot, they can sometimes generate it also, and they can be sources of ignition. The next thing we can look at is electrical arcs and sparks. Every time a switch is opened, a spark takes place across the contacts of the switch. So these are ignition sources. Atmospheric discharge. Oh, this is supposed to be lightning. We are lucky here in Oman, there is very little rainfall, and therefore lightning is limited. But in other countries, you would notice that during rain season, lightning is so much taking place almost every day when it is raining. And this can be a very, very dangerous ignition source. Mechanical friction impact sparks or impact sparks. These are happening when people who are in the mechanical department are working, filing for instance, hammering. All sorts of hard work can produce sparks. Electromagnetic radiation. I think you are aware that now when you are working, you are not allowed to take your phones into the plant because they can produce electromagnetic radiation that can be ignition sources. So really we have to adhere to the rules of our organizations that we should always leave our phones behind before we start or before we get into the plant. There are other ignition sources such as ultrasonic. These are sound waves or frequencies above 20 kilohertz, mainly used in the medical field. They can produce heat, but we are not very much interested in these ones since we would not be encountering them in our workplaces. Okay, compressing gases. Whenever an AC is running, it compresses gas, and when it's doing that, heat is generated. And again, the aircon itself, the outside unit of the aircon, becomes an ignition source. Last but not least, I want us to look at the chemical reactions that can be ignition sources, particularly for electrical people who do maintenance of batteries. I know you have got battery rooms where you carry out maintenance, and it is very important for you to be aware that the chemicals, that is the electrolyte in a battery, can produce heat. Because always when you are doing maintenance, you top up the battery level by adding some water into the battery. What kind of water? Pure water. So we must be aware that when we are doing this, we have to be careful because we can produce an ignition source by just doing our maintenance and doing it wrongly. We can actually end up producing some ignition sources. Open flames, this is obvious. Open flame, we're referring to things like cigarette lighters. A cigarette lighter is not supposed to be taken into the plant. It's a very big hazard. So I know every one of you knows that, and no one is going to be, or is going to try to use any cigarette lighter in the plant. So basically these are our main ignition sources that we must be aware of when we are working. Right. There are two terms which I want us to discuss today. These are, first one, the automatic ignition temperature. What is automatic temperature ignition? This is the temperature at which substances self-ignite without any other sources of ignition. Let me give you an example of what this is. For instance, if I were to take a barrel and pour some petrol inside the barrel and put it in this room, just by raising the temperature of this room to 220 degrees Celsius, the petrol will self-ignite. So when this substance self-ignites without any source of ignition, we say that at that temperature, that is the automatic ignition temperature. So most of the substances we use have got these self-automatic ignition temperatures. Why am I telling you this? I'm telling you this so that when you are doing any maintenance and you are using chemical substance which you are not aware of or which you have never used before, please try to get the material safety data sheet, MSDA. It's a very important document. It will tell you how to handle any substance which you have. So if you know the automatic ignition temperature of a substance, then after some maintenance, even if you are late for knocking off, you make sure that you take that substance to its rightful place. All chemicals should be stored in their rightful place. Don't just say, let me push it behind the door and then later on tomorrow I'll come and return it to the right place. Because you don't know the temperature, the automatic ignition of that temperature. What is going to happen is probably you'll find you start a fire unknowingly. So it is important for you always when you are dealing with substances to get the MSDS, the Material Safety Data Sheet. I hope everyone still remembers what that abbreviation stands for. MSDA, Material Safety Data Sheet. The next term which we want to discuss is the flash point. What is flash point? Here we are saying flash point of a liquid or viscous substance is the temperature at which sufficient vapor is given off to form a flammable mixture with air that can be ignited by a flame or a spark. If enough energy is released into this flammable mixture, it will ignite. So we are saying flash point, for instance, I know every one of us here have visited a fuel station, and if the petrol attendant is pouring fuel into your tank, you see something like fumes. That means the petrol has reached its flash point. From afar, you can see something is happening. It means that surrounding air is filled with some fumes of petrol. And I think that's the major reason why we are not allowed to light cigarettes when we are filling our petrol, because the petrol has already reached its flash point. There's lots of vapors or vicious substances in the surrounding atmosphere. So it is dangerous for us to maybe bring in a naked flame. I've got a table here of temperature classification, which we are going to look at. But before we do that, let's look at the surface temperature of explosion protected equipment, what it is. If the surface temperature exceeds the ignition temperature of a gas in an atmosphere surrounding the equipment, ignition will occur if the gas-air mixture is in correct proportions. Since ignition temperature of hazardous materials are different, all materials have got different ignition temperatures. It is not practical to design all equipment so that ignition was prevented from occurring in the most sensitive hazardous areas. Equipment is designed to operate within specific temperature ranges. So we have European standards, we have British standards, we have got national standards also, and these limits are called temperature classification T, against which all hazardous equipment is designed. So all equipment, most of the electrical equipment which you use in the hazardous areas, they will come with that letter T. T1, T2, T3, T4, up to probably T6. And this tells you the maximum temperature the particular equipment can operate to. So now look at T1. T1 means the maximum surface temperature of the particular equipment which has got that T1 is 450 degrees Celsius. When the equipment is running, fully operational, it will produce that temperature of 450 degrees Celsius. Often I can tell you that if I see an equipment with a T1, this cannot be used in zone 0, for instance, because zone 0, there is always some vapors there that are ready to ignite. So if I've got a surface temperature of 450 degrees, that is a hazard, a big hazard. So any equipment which comes with T2 is 300 degrees Celsius, T3 200, up to T6, which is 85 degrees Celsius. Maybe T6 would be the only equipment that I can probably install in, let's say, for instance, zone 1, maybe, because it has got a lower temperature, surface temperature. Right. Now, this is a range of other substances with their flash points and ignition temperatures. On this graph, you can see we've got acetal. The flash point is 20 degrees Celsius, which means at minus 20 degrees Celsius, acetal starts to produce those fumes. And it can ignite itself at 230 degrees Celsius. So you expose acetal to 230 degrees Celsius, it will ignite itself without any other sources of ignition. Just the temperature going up to that level, it will ignite. We've got acetal 66 degrees Celsius, that's the flash point, that's when it starts giving off those fumes. 245 degrees Celsius, automatic ignition temperature. And so on up to, then you can see benzene minus 17 degrees Celsius. But the surface temperature, or the automatic ignition temperature is very high, 560 degrees Celsius. Of interest is petrol again, which I have given as an example earlier on. Petrol has got a flash point of minus 45 degrees Celsius, which means if you bring petrol in this room, for instance, it is already on flash point. It's already to start giving fumes at this temperature, this room temperature we've got here. Remember, the aircon is running, but obviously we are above minus 45 degrees, which means flash point has already been reached for petrol. The automatic ignition temperature of petrol is 220 degrees Celsius. Interestingly, paraffin. I don't know if all of you know what paraffin is. We used to use paraffin in rural areas for light. Just put it in a bottle and a small cloth on top and you light it and you produce light. That is long back when electricity was not very much in rural areas. So paraffin has got a flash point of 38 degrees Celsius, but it can ignite itself faster than petrol. Paraffin ignites itself at 220 degrees Celsius. Why are we looking at all this? You would find that sometimes you might be using some of these substances as cleaning solvents. So you must be aware of their flash points and their automatic ignition temperatures. If you don't know that, then you probably not store them accordingly. Always there is a place reserved for storing these chemicals. You don't just leave these chemicals in the workshop. There is a special area where they must be stored. Even if you're in a hurry, make sure you return them back when you have finished work. It is very important for you to know that, because all the cleaning solvents, most of them, they've got automatic ignition temperatures. You don't have to have an ignition to ignite them. They will ignite themselves once they have reached a certain temperature. Okay, this is what we have already discussed earlier on, that flammable material, oxygen plus ignition, then obviously that's an explosion. Right. Hazardous areas and zones, very important in this lecture for us to understand this. Once hazardous areas and applicable zones are identified, potential ignition sources can be identified and either eliminated or controlled to prevent a fire or explosion. An ignition source provides a source of energy sufficient to ignite flammable atmosphere. We have already dealt with examples of ignition sources above. I know if now I ask you, everybody will be able to pick one or two or more ignition sources, since we have already discussed that. Controlling ignition sources. Controlling potential sources of ignition in hazardous areas may be achieved by, first of all, use of suitably rated electrical equipment. We don't have to pick equipment at random. We have to select the type of equipment that is going to be used in a particular area. I've got examples here of intrinsically safe or flame-proof. Okay, these are special designs done for equipment in the electrical instrumentation to say they are intrinsically safe or flame-proof, which means if any flame takes place within the equipment, it is contained, it will not go outside. Next thing, ensuring electrical equipment is effectively maintained. Where poorly maintained electrical equipment can present a significant risk. For example, worn out brushes. Electrical equipment requires maintenance regularly. So it is important for you to make sure that when the equipment is due for maintenance, it is carried out. You are not supposed to postpone maintenance. Maintenance is critical. Look at the example given there. Every time an electrical equipment is running, for example, a machine that uses brushes, if the brushes are worn out, they need to be replaced. Now, if you don't replace them at the rightful time, too much sparking takes place when the brushes are worn out. That's why we are saying now equipment must be regularly maintained. Right, the other thing is ensuring electrical equipment is properly earthed. Earthing is critical. Without earthing, we are actually having a hazard. I know a lot of you are moving around. Maybe some of you are not exactly in electrical, you're in the production, and you're moving around. You see loose connections of earth conductors. You have to report that. You have to report that so that your colleagues in the electrical department will go and maintain. What causes electrical conductors to be loose? There are lots of things. I know when they're doing maintenance, they make sure that the electrical connections are sound, mechanically and electrically sound. But what happens with vibrations now and again, the connections become loose. Once they are loose, that's a poor earth connection, and it is a hazard. So it is important for us to make sure that all electrical equipment is properly earthed. Okay, the next thing, ensuring the auto ignition temperature of hazardous chemical is considered. Some hazardous chemicals may ignite spontaneously above certain temperatures. We've already looked at the automatic ignition temperatures. And we know that once you have reached that temperature, the substance ignites itself. Implementing administrative controls such as permit systems, preventing hot work, for example, work being in these areas. Yes. So administrative controls such as permit systems, very important. You need to get these permits before you do any work. It is a hazard to just start doing some hot work without a proper permit system in place. Okay, the next thing, let's look at controlling ignition sources. Where electrical installations or equipment are required to be located or used in hazardous areas, e.g. lighting mixtures and steerers and pumps and control systems, forklifts, detectors, torches, etc. These items must be designed and constructed so that they cannot release energy within hazardous areas that is sufficient to cause an ignition. What are we saying? All equipment that is going to be used in the plant in hazardous areas, they must be specifically designed to be able to work in that area. So these days you would see equipment is written zone 0. That means that equipment must be installed only in zone 0 or zone 1 or zone 2 and so on and so forth. Okay. Controlling ignition sources. Such design and construction techniques include intrinsically safe or flame-proof or encapsulated equipment. Okay, there's a lot of jargon here which has been used: intrinsically safe, flame-proof, and encapsulated. Right, you learn about this at a later stage where we can show you what is an encapsulated kind of equipment, what is intrinsically safe later on. Any equipment designed and constructed to operate within hazardous area must also be supplied with documentation stating which zone. So we have zone 0, zone 1, and zone 2, those 3 zones. So equipment can come with a letter zone 0, which means this equipment can be used in zone 0. Zone 1, the equipment can be used in zone 1. Zone 2, it can only be used in zone 2. But let's look at it. If the equipment is written zone 2, you can't use it in zone 1. It is only for zone 2. But if equipment is rated zone 0, it means this equipment can be used in zone 1 or zone 2 if you don't have the specific zone 1, zone 2 equipment. If equipment is zone 1, it can be used in zone 2. But zone 2 equipment is only for zone 2 or free zones. Otherwise, zone 2 is only for zone 2. Zone 1 is the only one which can be used in zone 2. Zone 0 is the only one which can be used in zone 1 and 2. But zone 2 only for zone 2 or free zone. Explain it again. Or let me just go through it again. Zone 2 equipment for zone 2 or free zone. Zone 1 equipment can be used in zone 1 and zone 2. Zone 0 can be used in zone 1 or zone 2 or zone 0. Okay? So zone 0 can be used in zone 1 and can be used in zone 2, but zone 2 only for zone 2. Maybe at the moment that is what you have to take note of. Zone 2 only for zone 2, but zone 1 can be used in zone 1 and zone 2. Zone 0 can be used in zone 0, zone 1 or zone 2. Okay? Let's move on. Oh, this is just an example of a flame-proof equipment. This is, in most cases, you find this kind of equipment in the electrical department. So flame-proof, specifically EEXD. An explosion atmosphere may enter the enclosure. You can see the fixed 7 apparatus within the enclosure may ignite this explosive atmosphere. The enclosure is designed to withstand pressure. You can see the outside of the equipment is very strong. It's made out of very durable material, very strong. So any ignition which is going to, or explosion that is going to take place inside the equipment here is going to be inside. And only the cooled air will come out, will escape through those gaps that are designed only to cool the hot gases. So that's a kind of a flame-proof equipment. It's specifically called EEXD. So inside there you've got arcs, hot surfaces and so on. Even if an explosion takes place inside, it will be only for the inside. When it comes out, the air is cooled with those small gaps that are produced there. Let's look at what these zones, I've been talking of zone 1, zone 2, and zone 0. Let's look at what they are. Zone 0, a place in which an explosive atmosphere consisting of a mixture with air or flammable substance in the form of a gas. A vapor or mist is present continuously for long periods or frequency. That is the key word here. Present continuously. So always there is some vapors. And a very good example here would be inside the tank. Okay, inside the tank. The vapors are always there continuously. 24 hours, 7 days a week, every day, 366 days per year, you get those vapors inside. So that's zone 0. There's no time where you can say now there's no more vapors, they are finished. They are continuously present. Zone 1, a place in which an explosive atmosphere consisting of a mixture with air or flammable substance in the form of a gas. Vapor or mist is likely to occur. Likely is the key word. Likely to occur in normal operation occasionally. I'll give you an example of these zones on the third slide, I think. Right, let's move on to zone 2. We are saying zone 2, a place in which an explosive atmosphere consisting of a mixture with air or flammable substance in the form of a gas. Vapor or mist is not likely to occur. So the key word, not likely to occur in normal operation, but it does occur. If it does occur, will persist for a short period only. That's zone 2. Now let's look at the examples here. I think the graph I've got here, or the figure I've got here, is self-explanatory. Right, flammable liquid storage tank, situated outdoors, obviously, with fixed roof and no internal floating roof. This is what we have in every site. We have seen this. So we are saying zone 0 is inside the tank. The vapor is present continuously inside the tank. Zone 0 and zone 1. There's a breather there. You see there is a breather there. So sometimes, always when the pressures are at a certain level, it will vent and the gas will appear around there with dimensions that are purely theoretical. Right, and outside around the tank, that's your zone 2. Okay, so this is an example of your zone 0, zone 1, and zone 2. So we are saying zone 1, zone 0 inside the tank, zone 1 there on the vent, and outside around the tank we have our zone 2. Right, controlling static electricity. I'm not sure if everybody knows what static electricity, but I'll give you an example for the static electricity everybody has experienced in life. Let's take, for example, it's during winter time, people normally put on wool jerseys, and when you get into a dark room and you try to take off your jersey, you see some sparks taking place, or you hear sparks taking place. That's basically your static electricity. I've experienced this every time I'm trying to open a car door or even the door handle. I sometimes experience those shocks, and that is static electricity. It means I've got some stored energy. Maybe the clothes I'm putting on have got some certain energy, and when you touch metallic part, you are creating a path of low resistance, and they discharge. So when they discharge, you get the shock. So we are saying here static electricity can be created from a range of activities, including the transfer of hazardous chemicals or process fluids. This is the reason why you see electrical earthing conductors are on your process lines. And sometimes people wonder, why do we see electrical conductors on a pipe? It is for the purposes of trying to remove those stored energy, the static electricity within the pipe itself. So process lines and equipment should be earthed. Why? So that we create a path for them to be grounded, to go to the general mass of the earth through the earth conductor. So process lines and equipment should be earthed and bonded to ensure any build-up of static electricity is dissipated before hazardous electrical discharge can occur. So here we've got two words which might not be so clear with you. I know everybody knows what an earthing conductor is, but what is bonding? Bonding is basically when we use, again, either copper strips or copper conductors to join all metal parts to the general mass of the earth. That's bonding. If you have been looking in your homes, you have seen that if you've got water pipes that are metal, if you've got gutters outside, they are normally bonded. They are joined to the general mass of the earth through these copper strips. So while we are doing that, we are trying to create a path for any leakage currents to go to the general mass of the earth. Okay, so we can move on. Controlling hot work. Oh, we've already talked about hot work, but how do we control it? Hot work is any process involving grinding. I think I mentioned this earlier on, that the mechanical guys are mainly involved in hot work. So hot work is any process involving grinding, for instance, any process involving drilling, welding, oxycutting, heat treatment, or any other similar process that generates heat or continuous streams of sparks. Undertaking hot work in areas where flammable or combustible chemicals or other materials are present creates a significant risk of fire or explosion. So conducting hot work on containers such as drums, tanks, pipes that have not been properly decontaminated is a common cause of serious accidents. All over the world, people have died because of that. Hot work is very important for you to make sure that the place you are working at has been properly decontaminated. So hot work permit system is a very important thing. It's a system designed to eliminate or minimize risks from these activities by controlling and when, how hot work is undertaken in these areas. So ladies and gentlemen, once again, I want to emphasize that it is important that when you know that you are doing hot work, mainly the guys in the mechanical engineering or even electrical or instruments, make sure that where you are working, the system has been decontaminated. It is very important to make sure that has been done. Thank you, ladies and gentlemen. We have come to the end of this presentation. I really appreciate your cooperation, and I know I've seen a lot of guys taking notes here and there. It is important for you to adhere to the rules of the organizations when it comes to working in hazardous areas. I appreciate your cooperation. Well done. Thank you very much.